All right, today we're going to dive into a concept that honestly could completely change how we think about the internet. It's called unlinkable inference. I know, it sounds super technical, but stick with me because this might just be the key to what we're all looking for. Real, true digital anonymity. Let's get into it.
But first, let's start with a feeling. You know the one I'm talking about, that little voice in the back of your head that says every single thing you do online, every weird search, every random idea is being logged, tracked, and tied right back to your name. It's a little unsettling, right?
So for me, my big aha moment, the one that sent me down this whole rabbit hole, came from a really unexpected place, an AI image generator. I was just having fun with it, typing in all sorts of strange and creative prompts just to see what would happen. And then it just hit me. I stopped and thought, wait a minute. Are all of these prompts, these little glimpses into my brain, being saved somewhere? Are they being permanently connected to my account? I realized what I really wanted was just the freedom to be creative and experiment without building this massive, permanent, linkable profile of my every single thought.
And that feeling, that desire for a private space to just think, is what led me to this fascinating idea. So let's get right to the heart of it. What exactly is unlinkable inference?
Okay, so if you look up the official white papers from projects like the Open Anonymity Project, this is the definition you'll find. It's a method for getting a result from a server, but, and this is the key part, the server has no idea who made the request, and it can't even connect multiple requests to say they came from the same person.
I know. My eyes kind of glazed over the first time I read that too. It's a huge mouthful of technical jargon, so let's just pause, back up for a second, and ask the real question. What on earth does that actually mean for us, in plain English?
This analogy just nails it. Think about a library. The way most of the internet works now is the old way. You walk up to the librarian, you show them your library card, and you ask for a book. They see your face, they know your name, they know exactly what you're reading. Simple. Now, unlinkable inference is the new way. It's like you write your book request on a secret, coded note and give it to a trusted friend. Your friend goes to the librarian, hands over the note, and gets the book for you. The librarian fulfilled the request, but they only ever saw your friend. They have zero idea the book was actually for you. Your request is completely, totally unlinked from your identity.
So how is that magic trick even possible with computers? This is where it gets so cool. Let's peek under the hood at how it actually works. I promise we'll keep it super straightforward.
It really comes down to two main ingredients. First, something called cryptographic blinding. The best way to think about this is like putting your request inside a special digital envelope. The server can handle the envelope and get the job done, but it can't actually open it to see what's inside or who sent it. The second piece of the puzzle is distributed trust. Instead of just one trusted friend, imagine a whole chain of them. Your request gets bounced between several different independent servers. That way, no single server ever sees the whole picture. It's just a beautiful system. Of course, a technology this powerful doesn't just appear without any strings attached. Like any big new idea, it comes with trade-offs. So let's be honest and take a look at both the good and the bad.
Okay, so here's the core issue. It's that classic battle between privacy and performance. The big pro is huge, right? We're talking true user privacy. This is incredible for protecting sensitive questions you might have about your health or your finances, or even just ideas you're not ready to share. But there are costs. It takes more computer power, which costs more money to run. And as we'll see in a second, it can make things a little bit slower. And of course, there's the bigger question. With total anonymity, you have to think about how it could be misused if there aren't proper safeguards. It's a really important conversation to have.
And you can really see that trade-off right here. A normal, direct query is practically instant. We're talking 50 milliseconds. An unlinkable query, with all those extra privacy layers, might take around 250 milliseconds. Now, for most things we do, you would literally never notice that difference. But it is a measurable difference. Essentially, you're trading a fraction of a second for a massive leap in privacy.
Okay, enough theory. I think the best way to really feel this is to see it in action. So let's run through a quick, simulated demo of what it might actually look like to send one of these private queries.
So this is basically what it would look like on a command line. First, you'd start a new private session. Next, you'd use a blind command to wrap up your query. In our case, a cat in a spaceship, inside that special cryptographic envelope. And then you just submit it. See how that last command has no name, no account info, nothing? And that's it. The request is out there, the server processes it, and the result comes back. But the server has absolutely no log, no record, no idea that it was my computer that asked for a picture of a cat in a spaceship. That right there, that's the magic. That's that amazing aha moment when you realize the service still works perfectly, but your privacy stayed completely intact.
So if this is so amazing, you're probably asking the same thing I did. Why isn't this just everywhere? Why isn't everything built this way? And it's a really fair question. The truth is, there are some big, real-world hurdles. Like we talked about, it costs more in server power. It's also just plain harder for developers to build. And let's be honest, a lot of the internet's business model is built on linking your data. But maybe the biggest reason is that this is all still pretty new. It's early-stage tech, it's still evolving, and these kinds of huge fundamental shifts just take time to catch on.
But you know what? The fact that it's new is also what makes it so exciting. It means we can get in on the ground floor and learn about it as it grows. So if this has sparked even a little bit of curiosity in you, let's talk about some actual concrete steps you can take to explore it yourself. Here's a super simple 3-step plan. First, go right to the source. Look up the Open Anonymity Project and find their white paper. Yeah, it can be a little dense, but that's where all the juicy details are. Second, try out the sandbox. A lot of these projects have a public testing area where you can actually play with the commands and see how it feels. And third, join the conversation. Find the forums or online communities where developers are talking about this stuff and just listen in. It's honestly the fastest way to learn. I want to leave you with this one last thought. We spend so much time and energy trying to hide our data, manage complicated privacy settings, and cover our digital tracks. But what if the whole system was just private by default? What if the future of the internet wasn't about us constantly trying to hide, but about building systems where we had nothing we needed to hide in the first place? This feels like a real step in that direction.
Take this further. I'm genuinely excited to see what you discover. Comment with topics you'd like me to cover next, leave a rating, and subscribe if you enjoyed this explainer. Until next time.